Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Okay. So last class we discussed about what is energy, what are the types of energy, what are the types of renewable energy, what are the types of non-renewable energy, what are the benefits of renewable energy, what are the demerits of renewable energy, what are the benefits of non-renewable energy, also the drawbacks of non-renewable energy sources, and also we have discussed about the potential role and potential of the new renewable energy sources in global level as well as the country. Okay, so in this topic we are going to cover that. We are specifically we are going to study about solar energy, right? So certain types are there: solar heating application, solar cooling application, and solar electric application. There are three applications are there behind the solar, right? So what we are going to do is we are going to um, see about solar heating application, right? So we are not going to see solar electric application or cooling application. We are going to see solar heating application, right? So for that there are certain types of collectors. So the major difference is two types: flat plate collector and concentrating type collector, right? So in this topic we are going to study about the concentrating collectors, right? So flat plate collectors are um, uh, used for the small scale industries, or small scale applications, or the minimum amount of temperature needs. It will satisfy only the minimum amount of temperatures. But the concentrating collectors, it will easily achieve the temperature to the maximum easily. If the flat plate collector takes 2 hours, means concentrating collectors will take only 30-40 minutes. So this is the difference between, yeah, so concentrating collector is more efficient than flat plate collector, right? So okay, so straight away we will move towards the topic: concentrating collector. Okay, right. So concentrating collectors, high intensity solar radiation. So as I told, high intensity solar radiation, it will observe the high intensity solar radiation, and it will give the result as quick as possible than the flat plate collector. Okay. And it will observe the direct radiation as well as the diffuse radiation. So two types of radiations are there: direct radiation as well as the diffuse radiation. Diffuse radiation means some part of radiation will scatter somewhere else, so it will never allow the scattered radiation as waste, right? It will again recollect the radiation with the help of the concentrating collector dish. Okay, so direct radiation means only the direct radiation will can absorb. So the flat plate collectors are like that only, right? It will absorb only the direct radiation. So concentrating collector will absorb the direct radiation as well as the diffuse radiation. Okay, so small three instruments, major instruments which is used in this concentrating collectors are focusing device. Focusing device means where the radiation is there, it will automatically focus, right? For that only the tracking device also. So there will be a receiver, there is a focusing device as well as the tracking device. So tracking device is used to track the sun where the sun is located. So based on the movement of the sun, the collector also will rotate, right? So that is the use of the concentrator. So the receiver is nothing but it receiving the heat, receiving the radiation, because of the receiving the radiation, and the working fluid or the thermal fluid will get heated and we will use for the application. Okay, right. So there are certain types of concentrating collectors, parabolic collectors, mirror strip reflectors, Fresnel lens collectors, flat plate collector with adjustable mirrors. So these are the types of concentrating collectors, right? So now we are going to discuss about the parabolic trough collector. There are a lot of concentrating collectors also there. So we are going to study about parabolic trough collector. So this is the diagram of parabolic trough collector. So several models are there. This is another model for the large scale application. This is the small scale application. It will only give around 100 degrees Celsius, 100, degree, not more than 120 degree, right? So these are comes under the large scale application, right? So one by one we will see. Okay, so this is the basic structure of parabolic trough collector. Okay, or concentrating. In that concentrating collector, specifically we are going to study the parabolic trough collector. Right. Okay. So parabolic trough collector, the most preferable concentrating collector, most preferable concentrating collector, because that is what I told you. It will never never left any radiation from their receiver. This schematic diagram shows that it will never left any radiation from their receiver. In this, sun rays will fall on this dish, and it will scatter towards the receiver. It will never allow it to escape from the receiver. Okay. Again, here it will, once it is fall in the observer plate, it will reflect and it will again go to the receiver only. It will never escape from this receiver. Okay, so it is the kind of setup, based on this mechanism only they have constructed this solar concentrating collector, right? So I will show this one by one part. So this is the receiver, this is the receiver, right? So this is the reflecting dish, right? So this is again the pressure gauge which is used to control the pressure of the working fluid moving towards the tube, towards this tube. Okay, right. So this is again the storage unit. Here they have used like PCM based storage unit, right? PCM means phase changing material. So mainly, most commonly used phase changing material is wax. Okay, so this is a storage unit. The storage device is like wax. phase changing materials are used as a storage device, right? So this is the pump sector. It is used to pump the low pressure fluid to high pressure, because some ups are there, so we need a pump, external pump. We have to add some external pump. Okay, so this is the setup. This is the setup. So while the so it consists of the cylindrical parabolic reflector and the metal tube receiver at a focal plane. So as I showed, this is the metal tube receiver, metal tube receiver. Then the cylindrical parabolic reflector. This it looks like parabola shape, right? So parabola shape. So this is the parabolic parabolic reflector, and this is the metal tube receiver. So from the reflector, when the sun rays falls towards the reflector, and it will reflect the radiation to the receiver. It will never escape from this receiver. So this is the mechanism which is used to build this parabolic trough collector. Okay, so again, the length will be around the single parabolic trough collector length will be around 3 to 5 meter, and the weight is 2 to 3 meter. Okay, so the concentrating ratio will be 5 to 30. The highest temperature up to 300 degrees Celsius. Okay, so we can achieve this 300 degrees Celsius only because of this parabolic trough collector. You never get the 300 degrees Celsius degree high temperature in this, in the flat plate collector or any other collector. Only with the help of parabolic trough collector only we can achieve this 300 degree Celsius. Okay, so again, see the parabolic reflector, some specified materials are used. Highly polished aluminum of silverized glass. So two possible materials are there: highly polished aluminum of silverized glass, or aluminized plastic. So in this particular thing, highly polished aluminum of silverized glass is used. So this is a aluminum silverized glass. Okay, when you see in nature, it will reflect is it will look like a mirror, right? It look like a mirror, nothing but like this. Okay, right. So these are the specification about this basic parabolic trough collector. So here, when you are coming to this stage, so there is number of parabolic trough collectors are there, number of parabolic trough collectors are. What is the necessary for the, based on the application, we have to reconstruct the or add more parabolic trough collector. If for the small scale, it small amount, if you want small amount of heat, or only the single parabolic trough collector is enough. When you are going to an industry, they need enormous amount of heat. Enormous amount of heat means, basically in the industries nowadays, they are using LPG gas um, for the thermal usages. If they want, suddenly if they want some steam to remove the oil content from the particular parts, suddenly they go for, used to eject a gas, and by the help of the gas, the water get heated, and from the water the steam as we know, from the water, when it reach 100 degree, it will produce steam. From, because of the steam, they used to remove that oil content in the particular machine. So nowadays the industries have updated towards this renewable sources, like this parabolic trough collectors. So the concentrating collectors, they are going for this unit. So these collectors are not used for electrical purpose. As I told, we are studying only thermal applications, right? Okay, so um, so as I told already, so this shows the reflecting and observing diagram, right? So sun rays fall towards the reflector, it will reflect, and the receiver will observe the reflecting radiation. It never escape from this. Okay, so here some tracking devices are connected. So what is the use of tracking device? As I already told, so the tracking device is used to track the concentrating collector or the parabolic trough collector towards the sun based on the movement of sun from the direction. Okay, so once the position will be changed based on the time as well as the radiation fall on the parabolic trough collector. Okay, okay. So this is for large scale application. Again, this shows against the large application. See, 1 2 3 4 5, 1 2 3 4 5 6 7. So totally 35 trough collectors are there. Serious number of trough collectors are there. So this is the simple operation circuit diagram of this parabolic trough collector. So I will explain you now how we can produce the power from the trough collector, right? So these are the collectors. These are the collectors will receive the heat, right? So the working fluid, water, will be moving towards this tube, or the receivers, this towards the tube. Once the sunrise fall on the trough collector, the receiver will receive the heat from the radiation, and because of the radiation, the water flow towards the pipe will get heated, and that because of the heat, steam will generate, and that steam move towards the turbine, and the high pressure, this is the pump is used to give the low pressure steam to high pressure steam towards the turbine, right? So this is the turbine, and this is the pump. So pump is used to circulate the low pressure steam to high pressure steam. So this low pressure steam is passed towards the pump, and the pump um, will give some additional force towards the turbine. Because of this high pressure steam, the turbine will get rotates and connected with generator will, because of the turbine rotation, again the generator will produce the electricity. So this electricity will be used for the certain application, so for the future applications. Then some condensed amount of the high pressure steam will be passed towards the condenser, and it will get cooled cooled, and then again it will be recirculate towards the pump. Again it will be so this is the cyclic process, right? It will be again recirculated towards the trough collector. It will again get heated, and again the low pressure steam will be sent towards the pump. It will be converted, the low pressure steam, into high pressure steam towards the turbine. So again the turbine gets rotates. So the turbine, because of the turbine rotation, the generator will produce the electricity. So again the condensed amount of water will be sent to the condenser unit. It will condense the water to the low pressure water. It will be again recirculated. So this is the cyclic process. This is the simple schematic diagram of the parabolic trough collector, as well as the working of the parabolic trough collector. Okay, thank you.